I've got a cool video for you today. We are going to cover a lot, all in the realm of web performance debugging and fixing. This is going to be a practical video with lots of practical tips and tricks that you can start using today. Let's start out with the demo page. You can try this out yourself, by the way. It's cwv-guide.vercel.app. And I'm going to reload the page a few times just so you get a feel for how the page loads and what is actually going on. And we'll also take a very quick look at the code in a second. As for the page, I think one thing that stands out is the fallback font being used, and then that turns into a web font possibly, and that causes a bit of layout shift. There is also largest contentful paint issues, maybe, because it looks like that image is coming in late, or is it this image? Not too sure yet. We'll figure that out later. And as for the interaction, because there are 3 metrics as part of Core Web Vitals, the interaction to next paint, aka the latency of an interaction, that's this button right here. You can think of it as a call to action. In this scenario, it gets the dominant colors from this image. It's a pretty heavy JavaScript algorithm running in the background. Very quickly, we can verify some of these metrics by the Site Speed by Debug Bear Chrome extension. So just search for that in your search engine if you want to find out more and install this. CLS, Cumulative Layout Shift. Not an ideal score because there are a lot of layout shifts going on. And largest contentful paint, again, not great. And same with the interaction to next paint. We definitely want to get some of these measurements down. If we take a quick look at the page, apart from the page load process, we can see there's a header, a navigation, there's this banner, which if you recall, as we reload the page, the banner wasn't there. Then it says, please wait. And then some text just sort of randomly appears later. And as that text appears, it shifts a bunch of content on the page down. There is this featured section over here with an image and some text and a call to action. And there's a main content section down here, which is basically a bunch of paragraph tags with a corresponding image. And a footer, which isn't really relevant for this video. And a sidebar. And I think the images in that sidebar, yeah, they look somewhat lazy loaded, or maybe they're just slow, not too sure, but as they load in, you can definitely see little bits of text flicking around. It's not necessarily a prerequisite, but I want you to be armed with a bit of knowledge of this page. So if we take a quick scan through the DOM tree, you can see, oh, interesting, there's some script tags. They're potentially going to be large and maybe render blocking. Yeah, it doesn't look like the async or defer attributes are being used. And you know what? Let's use the sources panel to have a look at this. I'll make that a bit bigger. There are those script tags. So I think a piece of low-hanging fruit, as they say, would be to add at least the async attribute here. We've got a bunch of embedded CSS. Okay. There's that H1 that you can see on the page. The navigation, the container. Okay. Oh, interesting. So the images are here. At least the featured image is here. And whenever you see this question mark delay equals 1.3, that's an artificial delay that I've added to certain resources on the page just to help better demonstrate things and hopefully get this looking a bit more realistic. And if we carry on scrolling, okay, there's the main content over here. Yep, makes sense. Sidebar stuff. Okay, and scroll all the way to the bottom. All right, there's a font.css file. Colors.js, so presumably that's the color extraction algorithm. And we've got the main.js file, which presumably is the main JavaScript file for this website. And this is kind of interesting because it looks like there's some potential client-side rendering going on here, because it downloads a file called maincontent.json. It loops over that, creates a bunch of DOM elements, and then appends it to the page. That's something to pay attention to in a second. You understand how the page looks and feels, and you understand the basics of how the page is actually rendered because we had a quick look at the source code. Let's get started with the actual performance workflow. You've just been told by a stakeholder, by a customer, maybe it's yourself, that the website is slow. And that's really the only information that you're given. One of the first things you might try is to go to Page Speed Insights, put your website into this input box, click Analyze, and when you do, you'll get a report that looks like this. An important disclaimer for the rest of this video, we'll only be focusing on desktop because mobile is out of scope. There's already a lot to cover in this video. We don't need to look at SEO, accessibility, best practices. Let's just take a look at performance for now. And definitely our suspicions, if you like, are confirmed. The LCP, the largest contentful paint, is not ideal. That's a very high score. There's a lot of layout shift going on, hence a big cumulative layout shift score. And we can scroll down, we see some sort of screenshots as part of this film strip. We can filter, for example, for LCP related diagnostics, and then that filters down. But if we just take a look at all of them for a second, a lot of interesting stuff for sure. Properly sized images, that's a very sensible recommendation. And this is a nice place to start. And if you don't really have access to many tools, this is a decent place to start, and that should give you a clue for what to tackle next. What you could also do is go to the website itself, and maybe we should throttle the network actually. So if I hit that settings cog, sorry, it's right here, isn't it? Let's choose fast 4G, and I'll go to the Lighthouse panel, navigation mode, desktop device, just the performance category, and I'll hit Analyze Page Load. Let's make DevTools a little bigger. All right, so some interesting metrics here for sure. A high largest contentful paint score, high cumulative layout shift. So to be honest, this is very similar to what we saw in page speed insights. Next, I'd like to show you Debug Bear. We do offer a free website speed test, so you can come to this page, put in your URL, hit Start Test. I'm going to be using the paid offering just because it comes with some more features that would be pretty useful in this scenario. But if you want to follow along in this video, the free website speed test should be enough. This is the website speed test results for the page that we were just looking at. It's kind of nice because you get this lab score, and while the lab score is low right now, and don't worry, we're going to tackle that soon, as you hover over that lab score, you get to see what metrics actually helped contribute to whether it's a high or low lab score. But definitely, what we've been seeing is confirmed. There is a high LCP time. Apologies for the truncation, I'm just zoomed in for the sake of this video. That layout shift isn't great, it's a bit lower than what we were seeing previously, but these things you can experience a lot of variance between test runs with. You get this nice film strip, you get a video recording, which this is, to be honest, one of the features that I use the most, because the ability to actually scrub through and understand how a frame changed from one state to another, I find that very useful. And look, the LCP image is the rose as part of the main content section, which is interesting because intuitively you might assume it was the image a bit higher up. I scrub through that, and there, the image loads in. And also notice as the image loads in, it pushes the text that was below it, like down out of the viewport. So that's a bit frustrating. This nice LCP breakdown also offers some assistance. So you get the usual screenshot, right? But you also get a selector for the LCP element in question. We can see what that URL is, if it does represent an actual URL. I'm just curious if we open that in a new tab. Okay, one thing that does stand out is this is a very big image, and I'm curious, what is the file size? That's almost a megabyte, so that definitely needs fixing. Maybe we can compress that image. The point at which it's getting requested, the LCP request start time, that's pretty slow. I mean, it's not terrible, but it's not ideal. I feel that could be happening a lot earlier on. One of the worst things here is the request duration for that file. Almost 17 seconds is just way too slow. And that is no doubt connected to the massive size of the actual resource at almost a megabyte. This also stands out to me a little bit as well. Like, why is this request a low priority? Did you even know that requests have a priority? We'll try and dive into that a bit more. If we go to the requests tab, we do get some interesting information. We get this really nice waterfall, which, don't get me wrong, there's a lot of information to process, but at the end of the day, it's helpful and it's effective. I can see there are 2 blocking resources. They stand out as blocking because of the blocking badge. And maybe those resources would benefit from an async or defer tag, so we'll add that in shortly. If we scroll down, I'm kind of looking for this LCP resource, and it's very nice because it stands out thanks to the badge, but there's a lot of interesting information here. If I open this up, I can see that the priority was initially low. So I definitely want to keep that at the back of my mind and think about how I might tackle that. As we already noticed, the file size of this resource is way too big, so compression is definitely one of the solutions that we should use to fix this. But this is also standing out big time. Look how far down the list of resources that this LCP image is finally getting requested. It's not ideal. So it makes me wonder, is there an issue with the discoverability of this resource? I think we need to investigate that now. We know this file is called main1.jpg, and before we investigate, I want to briefly mention what is meant by a request chain, because I'm about to use that terminology. A request chain, if for example I open up this, it looks like there's a Google font, if I click on that resource, and I make sure that show request initiator chain is enabled. I know it's a bit hard to see, things are a bit zoomed in and a bit squashed, but what this will do is it will show you, okay, this resource came to be because of font.css, and font.css came to be because of, well, the main index.html, if you like. What would be interesting is to find out what is the discoverability story of the, what is it? The main1.jpg, I think it was called. There we go, main-1.jpg. Let's investigate. If I go into the network panel, reload the page. So this is the resource that is, yeah, main1, interesting, it's loading equals lazy. We should definitely consider how useful it is for that resource to be a lazy loaded image, considering, at least on desktop, it is within the initial viewport. But back to the network panel, in fact, I don't even need to search for main1, it's right here. If I click on the initiator, normally DevTools will be able to tell you, oh, here's the file which requested this resource. And every now and then you'll find out that that workflow is broken. I've got another little trick to show you. Command-Alt-F, at least on Mac, and I'll do a search for main1. Interesting. It will point out to me the file that references main1. Very good. And by the way, if you're questioning why are things happening in this way, this is recreating, if you like, techniques that I've actually seen used in the wild from back in the days, even up till now. These are very common patterns that you do see with some larger scale websites. And the whole point of doing things in this way, for example, using a JSON file to have some of the data that's rendered on the page, is to try and be a bit more realistic and make sure some of the fixes reflect what maybe even your production grade websites are doing. Back to the issue at hand, we've got this main1.jpg, and that comes from a main-content.json. So who's requesting that file? If we do a project search, okay, this is coming from main.js. And if I remember, main.js, if we zoom in a little, is right here. Okay, this now starts to tell a bit more of an understandable story. You've got the main page, which requests the main.js file. The main.js file is requesting the main content.json. The main content.json references the image URL. And back in the main.js file, that actually handles the client-side rendering of that data. Makes sense. One thing that does stand out to me, and because we were talking about discoverability earlier, and how early the browser knows to actually download the main-1.jpg file, well, this download for the JSON file is happening within a DOM content loaded. So I wonder if we can simply take this line out. Like, why do we have to wait for the DOM to start downloading some JSON file? If we can take that line out, that might help download the image a bit earlier. And just a little note on the priority, we did kind of see this earlier, but I want to recap. It starts out at a low priority and graduates to a high priority, which again, for the LCP image, I feel it would be nice if we let the browser know, hey, this is a high priority image from the get-go. At this point in my performance debugging workflow, I might come to the performance panel and simply make a recording. Full disclaimer, recordings can be a lot to process in terms of cognitively, just because there's so much information there. But there are a few things I would like you to pay attention to, and that is the rendering milestones at the very least. The rendering milestones are shown in this timing track, and you've got things like DOM content loaded, and it's a little bit hidden, but I think that's, what is that, FCP, first contentful paint. But really, we, at least at this point in the video, we're interested in LCP, and you can see the milestone is shown right there. And as I hover over that, the image of the rose, basically the corresponding DOM element, also highlights. And what's cool is I can also scroll down this recording and I can find out, okay, what resources potentially contributed to this LCP event. It looks like when the main1.jpg file finished downloading, that seemed to coincide with the LCP event. We've done a lot in the realm of investigating and identification of performance issues. I want to get to actually fixing these things. Remember, there were a few things there. There was the simple size of the image, which contributed to a slow download time. There was the discoverability, which meant the image resource was being downloaded a bit late in the process. And there was the weird issue of priority, which, by the way, that is shown in the priority column in DevTools. If you don't see it, just right click and make sure it is enabled here. Whenever you see stuff like low, high, that means it was initially a low priority resource and then it graduated to a high priority resource. Let's get fixing. One of the first things which I really wanted to do is make sure these scripts aren't render blocking, because I know for these particular JavaScript files, they don't need to be render blocking. Maybe your website will differ, but hopefully not. So add in a couple of async attributes. Next, I want to go to Scoosh.app, which is a really cool website to optimize your images. I'll drag in the main1.jpg and zoom out a little there. That's cool that you get to compare the unoptimized with the optimized version. And by the way, that is a massive saving, 86% saving. Really good. In this case, maybe I'll do a VIF. Wow, down to 32 kilobytes. I think it was almost a megabyte before. And we can also resize the image over here, because I think the resolution it was being displayed at didn't match the resolution that was being downloaded. I've downloaded the optimized image and I made sure to update all my file references to point to that new image, not just in the main content.json, but just throughout the index.html and basically anywhere the images were being referenced. Now all images on the website are heavily optimized and I'm hoping that will have a decent performance improvement. Moving on, I thought as a fix we could start preloading the request chain for the LCP image. If you remember, we had the main HTML file which requested the main.js file. That main.js file then requested the main content.json file, which in turn referenced the actual image in question. Now, if at this point you're saying, hold up, why don't you just embed the image directly into the markup? Thank you. You are absolutely right. That is what you should generally be doing. Don't use some clunky JavaScript rendering logic and behavior to get very simple content onto your page. However, with that being said, I do acknowledge that sometimes the architecture of a very large-scale website may not allow for that. And you may have to think outside the box with the type of performance fixes that you're putting in. Just to clarify, when possible, embed the contents directly into the HTML. When it's not possible, you can do something like this. Here, I'm preloading not only the main LCP element, but also the main content.json. And a massive disclaimer, you need to make sure you're testing these thoroughly. Sometimes when you add in fixes like these, for example preloads, you can actually end up making other stuff worse. These are now going to be downloaded very early on, which hopefully in our case improves things. I'm also adding this fetch priority hint because before the image was being requested as a low priority, and I've looked at that initial request waterfall and I'm happy to bump these up to the top of that queue. We added the async attributes to those render blocking scripts. We also optimized all the images used on the website. Now we are preloading the request chain, well, most of the request chain for the LCP image. Next, I want to open up the main.js file. Remember how the main content.json was being requested in the DOM content loaded callback? You could argue, by the way, that the preloads now combat against this and makes this potentially unnecessary, but regardless, we want to go for these best practices to make sure our code is intentional and intuitive to anyone else who might be reading it. In this case, we don't need to wait for DOM content loaded, so let's just put that fetch call directly out of the callback. And then it's just a case of awaiting that data promise, if that makes sense. One other small point, you might recall that the images are loading equals lazy, at least the ones which were supposedly going to be under the viewport, which it turns out, at least for the first one, it's not under the viewport entirely. And again, it is the LCP image, so loading equals lazy is like a questionable thing to be doing. When we get the array of objects from the main content.json file, we loop over it with a for each and construct the necessary DOM elements. All we really have to do here is make use of the index that for each gets and say, if the image is anything other than the first image, then you can use loading equals lazy. Just to be clear, there are 3 metrics to core web vitals. That's largest contentful paint, which we've just tackled, cumulative layout shift, and interaction to next paint. I know that you're eager to move along, but we need to validate the fixes we've just made. Who knows, maybe we made stuff worse. This is the web performance test result in debugbear for 01-fix-LCP. You can see that lab score has gone up, I think, so it's a bit better. Largest contentful paint, definitely a lot better now. It's showing in green rather than red. And if we watch that video, which makes things a little easier to digest, whew, yeah, that's a massive difference. So that image of the rows, the first rows, definitely coming in pretty early on. Yeah, around 1 second. And if we go to the request tab, look at that. Straight after the initial document, you can see the main one, what used to be JPEG, now the AVA file, is now being requested as basically the first resource after that main document. And the badges in debug bear are very helpful. It's telling us that it's fetch priority high, it is a preloaded resource, and it's the LCP resource as well. 15 kilobytes as opposed to 1 megabyte, very good. And also it's high priority. So no more initially a low priority, which could have caused issues with bandwidth contention. Now it's just high from the get-go. One small point, it was a bit confusing to have to remember what was the lab score previously before the LCP fixes. Debug bear does have this comparison view, which is very helpful for times like these, and you can see the lab score definitely has improved. You can hover over that to see what exact metrics are being factored into the score. And yet that largest contentful paint has just gone right down, really good. You get the film strip comparison with the largest contentful paint in completely different places, which is a good thing because it means we've improved. And the side-by-side video recording, I love. It's great to compare yourself to competitors and so on. But in this case, we're just doing it to see, have we improved? And to be honest, this LCP breakdown in the comparison view, this is really the crux of what we've done. We've gotten the LCP resource size right down. That start time is now happening a lot earlier in at 240 milliseconds. The download, the request duration for the actual image is again right down, probably because it's not a megabyte big anymore. Gone back to the test result for the initial problematic version of the demo page, and that's because I just wanted to point out one bonus feature for you, which is out of scope for this video, but at the very least it should get a mention because it is such a powerful feature. We show these performance recommendations at the bottom of a test result. And if you're like me, you look at these and you're like, time to go back to the code and have to figure stuff out. But for some of these recommendations, where it's applicable, we will give you this run experiment button. This isn't in the free website speed test, by the way. And we can inline these preloads for you or whatever the code is necessary for the recommendation that we've given. And as we give that to you, literally all you have to do is hit run experiment. And you can test these potential performance fixes within a matter of minutes without having to change your code and deploy it and so on and so forth. Definitely try that out if you can. Because we are covering so much in this video, I do want to do a quick recap of what we've done so far. The image was slow to download. How did we fix that? Well, instead of it being a JPEG, it's now AVIF, so that compression format led to a massive win in that sense. The discoverability of that resource, of the LCP element, was just terrible, and we addressed that by using preload tags to preload part of that request chain. Now the main content.json and main1 image file gets downloaded very early on. And finally, because earlier we saw some initial priorities of low, which graduated to high, we kind of hinted to the browser, hey, this should be high from the start. And to do that, we used the fetch priority high attribute on the preload tags directly. Let's move on to the next metric, which I really want to focus on, and that is cumulative layout shift. You can think of a layout shift as basically an element moving around the page, and it's maybe distracting or jarring for you or for the user. If I click on this metric, we actually get this dedicated layout shifts section. Then you get these human readable position changes. You can see that this element in question, it changed in its position, and that's very helpful to know because all of these little layout shifts can add up into a poor cumulative layout shift score. So lots of layout shifts to explore and look at here. And after having investigated that, what I'll typically do is I'll go back to the page in question, performance panel, clear the recording, and start a new recording. It's sometimes a bit tricky to find and to locate, but layout shifts do appear in the performance panel. They can sometimes appear as very small rectangle chunks, but they are there, I promise. If I slightly resize this, you can see there's a layout shifts track, and as you hover over this, different parts of the page will also highlight. And that hints to you, this element moved its position, it shifted in its layout. And you can also open the summary pane where you get a score. That one's not too big, but the cumulative score is pretty big. And it also gives you the size and the coordinates and the related node, which in this case, it seems to be out of the viewport. But anyway, you get the picture. Now, this might sound a little counterintuitive, but rather than spending all my time in the performance panel, one thing that I personally find very helpful is to use from the overview section, is to just use the video recording. Sometimes visually scanning for the layout shifts is actually the thing that I find easier. So do what works for you, but maybe try this workflow out. What are the layout shifts that we're seeing here? Look, in this case, there is a horizontal shift, I guess, because there's some text in the sidebar. And as these sidebar images load in, they seem to shift that text over to the right. And that's because the browser doesn't know how much space to reserve for these images because the images aren't ready yet. To be honest, that kind of makes sense, and it's something that we should be able to fix using something like CSS aspect ratio. Here we've got a bunch of paragraph tags, but the images, which were lazy loaded as well, they're not ready. As they appear, it pushes text down the page, and that could have been something I was reading. Fortunately, the fix that we apply for the sidebar images should also be applicable to the main content images, like the roses. If we carry on, this is another interesting one. Can you see that? It's the banner that loads in. Let's see if we can also use the DevTools screenshots. Here it is. There's the banner that randomly appears, and all it does is really say, please wait. Fair enough. And if we carry on scrolling through, at some point, text actually appears. Presumably that's coming from a remote resource. And one workflow that I find very helpful is to connect this transition change. If I suspect the network is involved, I can go to the network track and I can find out what resource coincided with that visual state change. In this case, I might need to zoom in a little bit more. Here is where the banner text loads in, and you can see that coincides with this banner text resource, which is conveniently right there. And we'll just double check just so we get a good picture of how this is working. You see that's initiated by the banner.js file. There's some very peculiar rendering strategies being used here. It appears that the banner is being created in the JavaScript right here. Then we give it some text that says, please wait. Then we append it to the DOM. But then it's only after being appended to the DOM where it says, please wait, that's when the fetch call is made. And the text response from that fetch call is then inserted into the banner. And just for completeness sake, let's double check what that resource looks like. This is the banner text endpoint, which, in case you're curious, for the sake of this demo, it's just a serverless function, which is as if meant to recreate this kind of API endpoint that you might get from other more large-scale websites. Let's continue. Ooh, that's an interesting visual state change. Here is the fallback font turning into what I presume is a web font. And that definitely shifts some things around. I think I recall seeing something to do with font in the request view. Okay, in the network panel, there is a font.css file. If I click on that, just a straight up import for a Google font. But if we look back at the screenshot, I feel there are two separate issues here. One is the speed at which this web font is loading in. And can I double check what is the name of that font? If we scroll down a little bit, it's Open Sans with a fallback font of serif. But it does feel like the two issues connected to the web font are, first of all, that the web font is coming in quite late in the process. So maybe as a little fix, we could possibly host this web font ourselves rather than using Google fonts. But then another thing is that the fallback font is just so different to the web font. They share no resemblance at all. And because of that, things do shift around when that web font actually comes in, because maybe its metrics are a little different, its dimensions, and all that good stuff. There's also another weird visual state change, which is definitely contributing to layout shift. And it's this. It seems the heading is randomly shrinking, and this stuff can be hard to debug. Let's try and figure it out in the performance panel. If we go back to the performance panel, I will start scrubbing through the screenshots, and there it is. It's this. See the heading of the featured section, it just randomly shrinks. And as mentioned, it can be tricky to debug, but similar to what I was saying before with the banner text, if we zoom into that segment, there we go, we can find out what resources coincided with maybe that state change. So there it is. It could be the JavaScript, maybe, if we scroll down. Oh, there are some dynamically loaded CSS files. I suspect the developer, me, had some extra CSS to add and maybe lazily just added it to one of these dynamically loaded CSS files. whereas really it should have been embedded into either the main HTML, considering it's sort of critical CSS, or at the very least just one of the CSS files loaded in earlier on in the page. If I double check in the sources panel, I'll open up that random1.css file. There's a CSS code that is overriding maybe some styles that the developer didn't want. And I'm sure we've all seen this before. I certainly have on many websites I've worked on. This would be some CSS which I'd feel pretty good about basically cutting and pasting, at least in the main HTML file. It's small enough and it should remove the layout shift, at least connected to this. I believe those are the main issues, so if we can fix that, that would be pretty good. And here we are in the code. I've added in my aspect ratio 2/1, and you might be wondering where I got that from. Ultimately, it depends on what aspect ratio you actually want for your images, but in this case, I was able to inspect the image, hover over it in DevTools, and you get this intrinsic aspect ratio 2:1 and rendered aspect ratio. But you can pretty much use the information in this tooltip to decide, can you copy the aspect ratio that's shown, or do you need to tweak it a little bit? Regardless, that's the fix. I've also added in a few other aspect ratio references. So there's the main content images, basically the roses. Those were 4:3. And one more, which is the images in the sidebar. And those are square images, and those images are square, hence this aspect ratio. Remember, the idea with defining the aspect ratio or the image dimensions up front is when the browser doesn't know the dimensions that the image will need to be displayed at, it can't reserve the appropriate space. And it's only when these images start to come in that things shift around, because for the image to appear in this viewport, it needs to push other stuff around. And here's a fix where we saw some headings randomly change in dimensions or in size. In this case, I'm happy to embed that CSS directly into the HTML file. Of course, in the real world, outside of a demo, this would realistically be in my main.css file. Moving on to fix number 3, I decided that we can simply self-host our CSS, and that's giving you a hint at the URL for the fixed version. But let's go through all these fixes first before we actually test it. But not much to say here apart from that, yep, it's being self-hosted now, as opposed to going to the Google Fonts domain. Of course, make sure you're complying with licensing when you do this. This is more about increasing the similarity of the fallback font with the web font. Previously, the fallback font was a serif, but Open Sans is a sans serif font, so we should use that. In this case, I picked Arial. Now, this funny looking code over here, which you may not have seen before, is out of scope for this video, but the gist of it is, instead of just saying Arial, I am using my own custom in quote marks, and you'll see what I mean by that, custom fallback font. And really, it still uses Arial under the hood. And by the way, I've got these different font-based declarations because it seems like you need separate versions for the bold variations. But that's kind of besides the point of what I'm trying to highlight right now. The idea being that by referencing this my fallback font, I can still continue to use Arial or whatever fallback font I want to use, but I can then customize it with these font-based descriptors. We've got some dedicated and in-depth resources on this subject exactly, as to how you can actually adjust these metrics to get the fallback font looking as close as possible to the web font to minimize that layout shift. We also discuss how you can use these generator tools to basically match up the fallback font so it looks as close as possible to the web font, hopefully decreasing any sort of layout shift. All right, that's enough of that. Let's go back to the demo page, or rather back to the source code. These values are not perfect. They are just very quick things that I've hacked together from some of these fallback font generator tools. Again, out of scope for this video, but please do play around with this. It can really make a big difference. We identified another issue being the banner. It was totally unusual the way it was coming in, wasn't it? If we go back to the film strip view, you can see that there's no banner, and then it comes in and it says, please wait. And then finally we keep scrolling and then just more text appears and it's all a bit confusing, these different state changes. Instead, how about we embed the please wait version of the banner directly in the HTML markup? Done that here. The please wait version of the banner is inlined into the initial server-side sent markup. Now, if we look at the banner JavaScript file, and by the way, just to repeat the disclaimer I mentioned earlier, if you can inline as much as possible into the server-sent markup, do that. The whole reason for this nuanced client-side rendering approach is because it's meant to reflect what I've seen in the real world. Anyway, now, instead of having to create the element in JavaScript, we simply pick it out the DOM and it already says please wait, and we only update the DOM once we've actually gotten the text. And by the way, bit questionable to use in a HTML. Inner text might be better in terms of security. At the very least, there should be some escaping going on, but that's a separate topic entirely. And where previously we were removing this decoration element, I think quite early on, now we mutate the DOM in batches, which is cleaner and also more performant, generally speaking. And here are those fixes applied. Again, things aren't looking perfect. I still see very subtle layout shifts with the text, but things are looking a lot better. You can see the browser now knows, regardless of it having downloaded the image, it knows what the image will eventually be displayed at, and it's able to reserve that space up front. There's no point of doing this stuff without testing it. Let's make sure we capture a performance profile. While removing layout shifts entirely is nice, it's not always going to be easy to do that, so that's fine. Don't be too hard on yourselves if you're not able to eliminate every layout shift. If I quickly check the site speed by debug by extension, all right, that CLS is looking a lot better. I think previously it was 0.1 and even 0.2 in another test run. Now we have the good rating for CLS, and I'm very pleased with that. If I shrink the network track for a second, you can see we still have a layout shifts track. Normally this track would disappear if you have no layout shifts. So don't get me wrong, there's still stuff going on. I think this is where the banner comes in, possibly. But you know what? This layout is really looking good at this point. The banner is not ideal, but again, thought I'd leave it in to reflect a bit more about real world scenarios. If we go to the debug bare result, we can see that lab score is now looking fantastic at 95%. If I hover over that, really good. Great cumulative layout shift score. We've fixed the LCP speed index. That's a great cumulative layout shift score. There's still a little bit going on, but it's not too bad. I guess that's connected to the banner, isn't it? Rather than doing a massive recap at the end, I'm trying to do these more ongoing recaps, which I hope is useful. To very quickly recap what we've been doing, we saw there were layout shifts connected to the transition between the fallback font and the web font. And to fix this, we did two things. We first of all used a more appropriate fallback font, in this case Arial, but also we played around with these font-based descriptors so that you can really tweak the metrics of the font to better match the fallback with the web font. We also addressed the issue of the browser not knowing how much space it needs up front for the various images that come in. And to fix that, we used the aspect ratio property and defined a width for all the images on the page. Finally, we inlined the initial banner into the markup, and there still is some layout shift when the banner contents finally does load in. But for argument's sake, let's just say we can't avoid that, and that's an acceptable trade-off. It's still far better than what it used to be. And before I forget, let's watch that video. A lot more satisfying. And there's the banner shift. Again, totally happy with that compromise. Maybe there are some future optimizations to be made there, but as a progressive improvement, very happy with that. If we go back to the demo page, which by the way, 02-fix-cls, that's the directory which contain all our fixes up to this point, you'll notice that yes, we fixed LCP, yes, we fixed CLS, or I should say improved rather than fixed. But what about that third metric? What about interaction to next paint? And as a reminder, that's basically a latency for an interaction. In this case, I click a button and it kind of stutters for a second. I can feel it. In fact, let me throttle the CPU by 6x, shall we say? Reload the page. If I open up the site speed by debug bare extension, right, interaction to next paint, waiting for user input. This makes sense. It requires user input. You can't easily capture this in a lab test. Let me click that button. Is it working? Oh my gosh. Yeah, that was slow. If I open up the extension, 2.7 seconds. So that is definitely a poor rating, and that will affect our overall Core Web Vitals score. We do have a real user monitoring solution, which once you've enabled in your site, we will capture real user interactions and a bunch of other interesting performance metrics and display that to you directly from the dashboard. But for now, while it would be interesting to look at all the other LCP and CLS metrics from real-world users, where instead of it being connected to this artificial lab test, it's actual field data, let's assume that we have addressed LCP and CLS to a satisfactory standpoint and just focus on INP. Whether you have hundreds or millions of page views, Debug Bear has all sorts of interesting ways of grouping that information. In this case, it's just me. So I'm going to go directly to the page views section, and each one of these rows represents a separately recorded page view. This column is highlighting some very slow INP scores. This one's 0 milliseconds, so maybe there just was no interaction there. But these I definitely want to focus on. I'll open this one, which took half a second. And with the INP tab selected, you can see it gives me the text of the interacted element. So that definitely is the Get Colors button. It gives me the selector, which is quite useful just in case it wasn't obvious. It gives a screenshot. Again, very handy, but this is so cool. If we open up INP scripts, it will show you all the scripts that were running as part of that interaction. And this is very helpful from debugging from the outside in, because it won't always be obvious to you where the slow JavaScript execution is happening. If I open that up, that's cool. We also get the code. I'm going to zoom out of debug there just so we can better see that. There's the callback function for the click event listener. And it looks like when we hit this Get Colors button, there is all sorts of interesting code happening which picks out those dominant colors as we previously spoke about. My genuine workflow for performance investigations like this is I will go from what we were just looking at, the page views or the various charts available in the real user monitoring section of Debug Bear. I'll go from that. And once I know roughly what I'm looking at, I can come to the performance panel and I will capture a recording of that interaction, hit Get Colors. Hopefully we waited long enough. And there it is. DevTools even has a dedicated interactions track so you can connect the main thread events to that given interaction. And you can also begin to find out what sections of code actually contributed to this poor INP score. A little bonus tip for you, by the way, if you click on the source code reference from the performance panel, it will instrument your JavaScript code. Well, it did that as part of the performance recording. And you get this very cool insight as to what functions basically took a lot of time. As I scroll down, you see there's various numbers in the gutter, and those numbers indicate how long that segment of code took to execute. Interesting. Looks like this was pretty slow. I quite like this example because it feels a little bit more realistic, and it's not got the sort of fix where I can just say, oh, instead of looping over 1,000,000 times, let's just do it twice and magically everything is fixed. No, we need to be a bit creative with what we come up with here. Before we put in the fix, you might have noticed it can be a bit tricky at times to get that INP score. Our Chrome extension does help here. There's the interaction to next paint score. But there's one other way that I want to show you. If I make sure that CPU throttling is on, and then we go to the Lighthouse panel, I will make a time span recording as opposed to a navigation recording. When I hit start time span, we have to wait maybe a second or two, and then it says you can now interact with the page. I'll hit Get Colors. Again, maybe wait a second or two just in case. Make this a little bit bigger. And how cool is that? The Lighthouse recording, instead of focusing on just page load, now focuses on just the interaction we recorded. And there's our INP score, along with an interesting diagnostic message. Now let's talk about fixes. I'm not an expert when it comes to color palette extraction from an image. So rather than changing the algorithm which is being used, I'm going to change the way the code is being run. Previously, this function was something like process image on main thread. So I'm going to change that to process image web worker. And I'm going to use this really powerful web platform feature known as web workers, which can run the code that you give it on a separate thread that doesn't block the main thread. If we go to the function source, you can see this is where I initialize the worker. The best part, the source code of the worker.js script basically stays the same as when it was previously running on the main thread. With that seriously tiny change, let's go back to the web page. And by the way, this is the fixed version. That's /03-fix-INP. And we were previously using the time span feature in Lighthouse. So let's carry on using that. Make sure time span is selected. Start time span. Okay. Get colors. Interesting. So it still took around half a second. That part isn't really getting any faster. But hey, this is looking better. Interaction to next paint of 60 milliseconds. That's fantastic. And in fact, we can even go to the performance panel. You'll see something quite interesting here. If I start recording while I'm clicking on this button, maybe give it a second or two, stop the recording. Might have to make DevTools a bit bigger here. You can see the main thread wasn't blocked up, whereas previously it would have been. However, if I shrink the main thread track, you see we've also got a worker track. And that indeed does show the heavy JavaScript activity. But notice this was still a very costly operation. So what's going on? Before I explain, I do want to just double check our extension as well. Open the extension pop-up. Waiting for user input, it can't show us an INP score. Okay, hit get colors. Fair enough. Look at that interaction to next paint score. So much better. But again, if there was still 400 milliseconds of JavaScript activity, how are we getting such a good INP score? Well, the magic is all in the main thread versus the worker thread distinction. As long as our heavy JavaScript code is happening in the worker thread, it frees up the main thread to continue processing the page, and it allows for those subtle visual updates that were maybe being delayed by too much previously. In fact, here's a very good way of visualizing it. If I go to the performance panel and I make sure to throttle maybe by 6x, that's the CPU, watch this. Every time I hit get colors, I can still select stuff on the page, even if it's taking a really long time. In fact, I wonder if CPU throttling applies to the worker JavaScript, but regardless, this illustrates my point. As I'm hitting get colors, I can still interact with the page by highlighting text. If I go to the previous iteration of our fixes where we just addressed LCP and CLS, but not yet INP, let's see what happens here. So I hit get colors and I can't select anything on the page. And when finally the dominant colors or the color palette does appear, it's as if all of my queued text selections happen at once, and it's very confusing and jarring. I'll do that once more. So I hit get colors, and right now I'm clicking and selecting stuff on the page, but nothing happens at one go. You might be wondering, how do we visualize this in a lab test? And what's really interesting is the debug bear result for the INP fix, which also includes the LCP and CLS fixes, appears to be pretty much identical to the previous fix where we only fixed the LCP and CLS. Apologies for the constant acronyms here, but can you guess why the lab scores are identical? Well, it's because this is just a lab test. There is no concept of the user in this test that we've just made. How do we validate the fix that we just made in debug bear? Well, the process should look a little like this. You go to the real user monitoring section. In this case, we're just interested in INP, whereas previously this score was really bad, which by the way represents the 75th percentile, which you can read more about on our website. In this case, the INP score is perfectly decent. And if I inspect the page views just to get a better understanding of things, I don't see any INP scores which are really standing out to me. And that is a strong signal that we have fixed the issue. We just covered a lot in that video. I do hope you enjoy it, and I do hope you're able to pick up 1 or 2 interesting workflows that you can now adopt into your own performance debugging and fixing workflows. If you do want to follow along with this demo, here's the URL. That's cwv-guide.vercel.app. Hope you enjoyed that. See you next time.